In this video, we are going to learn about metal deficiency defect. Metal deficiency defect is one of the non-stoichiometric defect. In non-stoichiometric defect, there are two types. One is metal excess defect that we have seen in the previous video. Now we are going to learn about metal deficiency defect, which affects the stoichiometry. Stoichiometry means that the number of cations, anions number is unbalanced. So here, metal deficiency defect arises due to the presence of less number of cations than anions. Mostly this defect is observed in which the cations have variable oxidation state. Cations have variable oxidation state. Best example, FeO. Before the defect, the formula is FeO. After the defect, the formula becomes that experimentally, due to experimentally determined formula, FeXO. X ranges from 0.93 to 0.98. That is less number of cations when compared to anions. This only we are going to see in the video. So here metal deficiency defect means less number of cations than anions. Cations having variable oxidation state. Example FeO. Before the defect, after the defect, the formula becomes FeXO. X ranging from 0.93 to 0.98. Now we are going to see the defect, how it is happening. FeO. Here Fe having +2 oxidation state. So Fe2 plus O2 minus, 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 Fe2 plus O2 minus. So before the defect, we can count the charges. Fe2 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 Fe2 plus O2 minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. O2 minus 10. So the charges 2 plus 10 atoms present. So 20 plus O2 minus 10 atoms present. So 20 minus. So this charge get cancelled now. 20 plus 20 minus 0 charge. That is nil charge. So it becomes neutral. Neutral means equal. There is no defect. Suppose here in the defect, suppose if some of the Fe2 plus ions missing. So due to that defect, if suppose one of the Fe2 plus ions missing, so what happens now? Fe2 plus O2 minus, Fe2 plus O2 minus, Fe2 plus O2 minus. One of the Fe2 plus missing here, vacant place, O2 minus, Fe2 plus 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 O2 minus. So here one of the Fe2 plus ion is missing now. So what happened to maintain the neutrality, electrical neutrality? Twice the number of so now you see here, while we're counting here, Fe2 plus 1 2 3 4 5 6 7 8 9 9 Fe2 plus present, O2 minus 1 2 3 4 5 6 7 8 9 10 O2 minus. So here only 18 charges, 9 2s are 18, here 20. So here 18 positive ion, 20 negative ion, 2 minus charges extra having. So it needs 2 plus charge to balance. It needs 2 plus ions. It needs 2 more plus charge to get balanced. So what happens? So in the vacant place where Fe2 plus ion is missing, near that ions present, near that means here and Fe2 plus, and any one of the Fe2 plus ions get oxidized to Fe3 plus ions. Maybe this or this or this or this or this. Any two of the Fe2 plus ions. Consider these two. Fe2 plus now get oxidized to Fe3 plus. Fe2 plus get oxidized to Fe3 plus. So what happens now? So Fe2 plus, you count it now. 1 2 3 4 5 6 7. Fe2 plus 7. Oxygen as it is 10 only. 1 2 3 4 5 6 7 8 9 10. Oxygen O2 minus 10 only. Count Fe3 plus. 2 Fe2 plus converted to Fe3 plus, oxidized to Fe3 plus. So Fe3 plus 2. So here number of positive ions is less only. Here 7, here 2, 9 only, but here 10. So anyhow, whether it is balanced, Fe2 plus ions, if so it is balanced, but the number of charges Fe2 plus and Fe3 plus less than O2 minus ions. To maintain the neutrality, twice the number of Fe2 plus ions in the crystal, even though oxidized to Fe3 plus ions. The overall number of Fe2 plus and Fe3 plus ions is less than O2 minus ions. So experimentally it was found that FeO, that now formula becomes FeXO, and the X range is ranging from 0.93 to 0.98. So it becomes less when compared to O2 minus ions. So in the crystal of FeO, the missing Fe2 plus ions and the loss of positive charge is made by the presence of required number of Fe3 plus ions. Even though it is balanced, there is less number of ferrous ions than oxide ions. Less number of ferrous ions when compared to the oxide ion. This is called metal deficiency defect. Even though it is oxidized, even though it is not balanced, the charges, there is less number of cations, that is ferrous ions, when compared to the oxide ions. That is called metal deficiency defect. So this is one of the non-stoichiometric defect. Non-stoichiometric means unbalanced. Cations as well as the anions are unbalanced. That is called non-stoichiometric defect. Mostly this defect can be found in cations having variable oxidation state. That only we are seeing here, Fe2 plus 3 plus, having even plus 2 valence state, even plus 3. Such ion only can take up this process. So So it was previously it was said that cations having variable oxidation state only can prevail this defect. It was proved by that Fe plus ions. So it is given clear, not clearly. Some extra points I have given in this video. You can go through. It will be understandable. This is given in book page number 195.